well, let's get into this. It's actually a really lovely section and quite interesting. The fundamental counting principle basically deals with the number of ways in which something can happen. So something, whatever it might be. So the number of ways in which something can happen. All right, and we are primarily concerned with when things can be repeated. So repetition is allowed, or when repetition is not allowed. Okay, so things that can always be repeated are things like letters and numbers. If you're dealing with people, then people can never be repeated. Okay, so it's important, especially when we are dealing with things with letters and numbers, that the question specifies whether repetition is allowed or whether it is not allowed. Okay, and we'll talk about the difference between these. Okay, so just the fundamental basics. If we are talking about a meal, and the meal can be made up in the following way. So choice 1 is meat, fish, or chicken. Choice 2 is mashed chips, potato, rice, or vegetables. What we would do is we would count the number of ways in which choice 1 can happen. That would be 3 different ways. And we would count the number of ways choice 2 could happen. That would be 5 different ways. And that would give us a choice of 15 different meals. So it's a shortcut. Instead of us going meat and mash and meat and chips and meat and potato and meat and rice and meat and vegetables, and then fish and mash and fish and chips and fish and baked potato, and counting it up that way, we would use the counting principle by multiplying the number of ways in which the one can happen by the number of ways in which the other one can happen. Okay, that's the basics of it. Just another example, just a little bit more going on here. A gift pack can be made up of the following. So choice number 1 is choose 1 out of 4 possible CDs. So 4 ways in which you can choose a CD. Choose 1 packet of chips out of a possible 5 different types. There would be 5 different ways in which choice 2 can happen. Chocolates, there are 12 different chocolates, so choice 3 can happen in 12 different ways. And 1 type of fruit out of 3 different fruits, there would be 3 ways in which that could happen. All right, so what we would do here is we would multiply all of those numbers together. And that means that there are 720 different gift packs that could potentially be made in this way. Any questions so far? We're still just doing the easy stuff. No questions? Okay, so you guys do this one on your own. Please explain where your answer comes from as well when you do your working out. Don't just write down the answer only, and then you can share it with Yolanda or I. How many different party packs can be made? What are you guys getting as an answer? Okay, Mbali, good. Yes, Nondamiso. Yes, Chloe. Yes, iPhone, Lasidi, all good. Okay, so not a difficult question at all. All right, 4 by 5 by 3. So there are 60 different types of party packs that can be made. Excellent, well done. All right, let's move on. So in example number 3, they give us the word Parktown. and they say they want us to form different 8-letter word arrangements using the letters of the word box down. An example of the word arrangement could be something like that. This arrangement of letters does not need to make any sense. It doesn't need to make another word. How many possible word arrangements can be made if A, the letters may be repeated? Does anybody know how many different letters or possible word arrangements can be made if the letters are allowed to be repeated? What would we do? Does anybody know? Okay, Zoom user, good. I'm glad you DM'd me. Thank you. Okay, so one person has sent me what they think we'd do. What about everybody else? Nkonizer. Okay, so some people saying something slightly different. So some people saying 8 factorial. Okay, so some of you are saying 8 to the power of 8, and some of you are saying 8 factorial. So first of all, what does 8 factorial mean? What does 8 factorial mean? Okay, so Trish says it means 8 by 7 by 6 by 5 by 4 by 3 by 2 by 1, which is perfectly correct. Okay. In this question, it told us the letters can be repeated. So in the first block, we've got 8 different ways in which we can fill the first block. But if we're allowed to repeat our letters, it means we would have 8 different ways in which we could fill the second block as well, and 8 different ways to fill the third and the fourth and the fifth and the sixth and the seventh and the eighth. So the correct thing for the first one is 8 to the power of 8. Okay, because repetition of these letters is allowed. Okay, so that would be a massive 16,777,216 possible word arrangements. In part B, the letters may not be repeated. This is when you would use 8 factorial. Okay, because there would be 8 ways in which you could fill the first block. But because you've chosen a letter, the letters are not repeated themselves. There are no identical letters. Not that that's actually part of our syllabus, it isn't. There are no identical letters. So if you've taken the T, there are now only 7 letters left. If you now take another letter, there are only 6 letters left. Then 5, then 4, then 3, then 2, then 1. And that is 8 factorial. Okay, and as you said, Chloe, it would be 40,320. Okay, so when letters can be repeated or numbers can be repeated, then you would use exponential notation. But if repetition may not occur with letters or digits, that's when we would start using factorial notation. Is everybody okay with that? You can see the difference between the two. Okay. Okay. So quick, let's just double check we're all cool with that, and then we can move on. So you guys answer this question. Yes, Sihle. The rest of you can carry on. I'll take Sihle's question. Yes, Sihle.
Hey man,
Hi, Sihle. How are you?
I'm fine.
That's good.
Um, can you please explain to me when we get in a sum right which says the letters may be repeated?
Mm-hmm.
That's when I'm confused.
Okay, so if letters are allowed to be repeated, okay, so if we take the same example before, okay? You've got 8 different letters to choose from. So if you chose a P the first time, you could choose a P the second time, or an A or a K, or an R or a T or an O or a W or an N. And then when you fill the third block, again, you've got that choice of 8 different letters. And so that pattern is repeated. That would be the 4th block, the 5th block, the 6th, the 7th, and the 8th block could all be filled by one choice of 8 different letters. That's why it's 8 to the power of 8. Okay, so that's why we're using exponential notation. Okay, because we're multiplying something by itself. Okay, whereas the factorial notation, letters cannot be repeated. So that means each time we have one less way in which we can fill a particular block. I hope that answered your question, Sihle. Cool, Jude. Yes. Did Sihle say he was okay?
Yeah, not really, ma'am.
Okay, what are you struggling to understand?
The, I think like the how to execute it.
Okay, so if we take the word Florida, okay, we've got 7 different letters. So how many different word arrangements can be made if the letters can be repeated? Okay, each block. So think about it like this. You are filling a block. The first block is for the first letter. The second block is for the second letter. 4, 5, whoopsie, 6, 7. So there are 7 ways that block can be filled by 7 by 7 by 7 by 7 by 7 by 7. So that would be 7 to the power of 7, which leaves us with some massive big number. You guys have sent this through. 8, 2, 3, 5, 4, 3. Then if letters cannot be repeated, so that's question A over there. Let's do that rather. Now, if the letters cannot be repeated, each time, Sihle, there'd be one less letter available until they were all used up. So in the first case, there would be 7 letters, but once you've used one, it can't come up again. So then there would be 6 letters to fill the second block. By 5, by 4, by 3, by 2, by 1. So that's why for B, we would say 7 factorial. Okay, which is 5040. Yes, Sihle.
No, I think I'll get it. Thank you.
You think you get it? Okay, all right. Well, let's just let it go through. Let's go through the lesson and let's just see how you do with the next things that come up, because a lot of this is quite repetitive. Okay, let's have a look at this example. This is a really nice example. Okay, so a password is to be made up using the format XXXYY, where X represents any digit from 0 to 9 and Y represents any letter of the alphabet. The question asks how many different passwords can be formed in each of the following cases. All right, so in case A, we'll get that down now. Let's just remember our format. So we've got 3 blocks with the X's. So this is an X, this is an X, this is an X. This is a Y, and this is a Y. Now remember, the X is a digit, and the Y represents a letter of the alphabet. So if we're working with digits from 0 to 9, excuse me, sorry about that, everybody. How many different digits are there if we include all our digits from 0 to 9? How many different digits is that? Exactly, it's 10 different digits. Good, everybody. So in how many ways can we fill the first block? Because remember, it's saying to us here, the digits can be repeated and the letters can be repeated. So how many ways can we fill the first block? In How many ways? In 10 ways. Because we're allowed to repeat things, there would be 10 ways in which we can fill the second block and 10 ways in which we can fill the third block. Now we move to the letters. How many letters in the alphabet? 26. Perfect. So if letters can be repeated, there are 26 ways in which we could fill that block, and there would be 26 ways in which we could fill the last block. So we could write this as 10 cubed times 26 squared. Okay, 10 cubed times 26 squared gives us 676,000 different passwords that could be formed. Now they tell us in part B that the digits may not be repeated. The letters, sorry, it's not phrased very well. The digits and the letters may not be repeated. So in how many ways can I fill the first block where the X would go? In 10 ways. Cool. In how many ways can I fill the second block where a digit can go? In 9 ways. Excellent. In how many ways can I fill the third block? Good, by 8. Now I'm switching over to letters of the alphabet. In how many ways can I fill the first block with a Y in it? 26. And the second block allocated for letters of the alphabet would be 25. Well done, everybody. So this is 10 by 9 by 8. I cannot use exponential notation. By 26 by 25. Well done. So 10 by 9 by 8 by 26 by 25 gives us 468,000. So a lot less ways when repetition is not allowed. Lovely, well done. Let's look at question C. Now they say to us, the digits and the letters can be repeated, but the number 0 and the vowels must be excluded. All right. So if 0 is being excluded, how many digits do we have? 9 digits. And if we're excluding the vowels, how many letters do we have? Exactly, 21. Okay, so here, because repetition is allowed in this case, it would be 9 by 9 by 9, which is 9 cubed, by 21 by 21, which would be 21 squared. Does that make sense to everybody? Yes, see how you can use factorial notation. Nice question. So see how was asking, can I use factorial notation for question B? Yes, but there's a but here. See how? What do we have to do? Okay, so I was going to get into this a little bit later, but I'm happy to talk about it now. Does anybody know? Can anybody help see how? How could we use factorial notation to answer question B? Can anyone tell us? See how wants to know. Divide. Ah, there we go, Sinanhlanhla. Well done. Okay, so Sinanhlanhla has messaged me and they've said we must divide by the repetition. So Sinanhlanhla is quite right. Now, I don't know if the rest of you have seen this before, but what we could do, because we want 10 by 9 by 8, we could say 10 factorial and then divide by the repetition. So we don't want 7 times 6 times 5 times 4 times 3 times 2 times 1. So we can divide by 7 factorial. Then as far as the second bit goes, so 26 by 25, that would be 26 factorial, but now we don't want from 24 factorial onwards. So we could do it like that, see how? Okay, and then we can use factorial notation. Just double check, but it should give us the same answer. Does that make sense to everybody else? Okay. All right, nice question, Sihawu. Thank you so much. I really enjoyed answering that. Okay, let's have a look at question D. The digits and the letters may not be repeated, and the number 0 and the vowels must be excluded. Okay. All right, Amatli is asking me to explain it one more time. If there are others that understood that, you are welcome to have a look at questions D and E, and I will explain it again. Amahle? Probably not the best question to explain this on, but the idea here is that we divide by what is being repeated. So let's say I just want 10 by 9 by 8. When I write 10 factorial, that means 10 by 9 by 8 by 7 by 6 by 5. Let me just create some more space here. Let's just go one back in case anybody was looking at that. By 4 by 3 by 2 by 1. Okay, so you don't want 10 factorial. All right, you want 10 by 9 by 8. So that means that from the 7 onwards, we want to get rid of that. So we would divide by 7 by 6 by 5 by 4 by 3 by 2 by 1. So that division can take place, because anything divided by itself leaves us with 1. Does that make sense? Okay, so at the bottom, that's where the 7 factorial comes from. Okay. All right. So Blessings offered an answer. Thank you, Blessing. For question D. Okay, cool. So Blessing says for question D, the digits and letters may not be repeated, and the number 0 must be excluded. Let me go and have a look at your answer again, Blessing, because you're the only person who sent me an answer. Nice. Good. So Blessing sent me the right answer. What about the rest of you? Question D, everyone. Okay, lovely. Well done, everybody. Good. Okay, that is correct. Okay, so what they're saying is this. They're saying, oopsie, not starting with 10, sorry. We're starting with 9. So 9 by 8 by 7 for the blocks with numbers or digits in them, by 21 by 20. Okay, where the letters go. 9 by 8 by 7 by 21 by 20 is, as you guys said, 211,680. Cool. All right. Question E. The digits may be repeated, but they must be prime numbers. And the letters may be repeated, excluding the first 5 letters and the last 5 letters. So how would we do question E? What do you guys think? How many of the numbers we've got are prime numbers? Okay, so the rest of you think about that. Iola, you are excluding 0. Okay, so that gives you 9 digits. Remember, the first 3 blocks contain digits. So if you've used one of the 9 and you're not allowed to repeat, there are 8 possible digits for the second block and 7 possible digits for the third block. So you've used your numbers. Then as far as the vowels as the letters are concerned, we're excluding the vowels. So it's A, E, I, O, U. There are 5 vowels. 26 letters minus the 5 vowels gives us 21 letters to choose from when we fill the first block containing a letter. Because repetition is not allowed, there would be 20 letters available to fill that last block. Okay, Iola? Good question. So Sihawa says there are 5 prime numbers. Masejo says there are 4. Katleho says, is 1 a prime number? Is 1 a prime number, guys? Let's answer Katleho's question. Okay, why is 1 not a prime number? Why do we not consider 1 to be a prime number, guys? Lesejo and Jude both saying no, that is correct. But why? Why is 1 not a prime number? Yeah, so Katleho, you're right. 1 can only be divided by 1. So for a number to be a prime number, it can only be divided by 2 numbers. Okay, 1 and itself. Nkuniza's got the answer already. Nkuniza, you speedy there. Okay, so there are 4 ways in which we can fill the first block. So the digits may be repeated, but they have to be prime. So it would be 4 by 4 by 4, and we're excluding the first 5 letters and the last 5 letters. So how many letters are available for the blocks where the letters go? 16, indeed, Masejo. But because we're allowed to repeat, we can have by 16 again. So 4 cubed times 16 squared. Okay, so 16,384, which I think is what you guys were. Yes. Yes, Katleho. Okay, Jude, that's correct. Okay, we all happy with that? Are we all thumbs up? Cool. Okay, Nkuniza, prime numbers are numbers that can only be divided by themselves in 1. So 2, 3, 5, and 7 are the only prime numbers when we consider the digits from 0 to 9. Okay. Yeah, between 0 and 9, it would be 2, 3, 5, and 7. Okay, Nkuniza. No problem. All right, let's have a look at this question. Okay, so this question is about buses. Okay, so there are 4 bus lines between town A and town B, and 3 bus lines. So it's like a route. A line, they mean a route, okay? And 3 bus lines between town B and town C. So question 6A says, in how many ways can a person travel by bus from town A to town C by way of town B? What do you think? So you have to go, you're going from A to C through B. So first you have to go from A to B, and then you've got to go from B to C. And how many ways can this happen? What do you think, Matrix? Yes, it is. So Nkuniza has asked me if their answer is correct, which it is. What about everybody else? And how many ways can you get from A? There we go, Lucidi. That's it. Yes, Iletu. Beautiful. Okay, so 4 ways from A to B, by 3 ways from B to C. So there would be 12 ways in which you could go from A through to B. So A through to C. In question B, in how many ways can a person travel return trip? By bus from town A to town C by way of town B. I agree, Nkoniza. There's no one said that so far. But I agree. Okay, now whoever's put Masejo, good. I like the way you've put that. Okay, so it's not 12 because you're going there and you're coming back. Okay, so let me show you what Masejo and Nkoniza sent me. Okay, 4 by 3 gets us there. By 3 by 4 gets us back. So that would be 144 ways. Okay. Yolanda, please will you just help iPhone 2 in this case?
Yes.
Thank you, whoever that may be. Let's have a look at question C now. In how many ways can a person travel return by bus from town A to town C by way of town B if this person doesn't want to use a bus line more than once? Because Katleho R, you have to go back via town B. Okay, so if there are 4 by 3 ways for you to get there, then there are going to be 4 by 3 ways for you to return. Okay. All right, Chloe's giving me an answer here. Let's see. There we go, Chrissy. Nice. Yes, and Nkoniza, lovely. Well done. Yes, both of you are correct. Good, lovely. Yes, Lorato. Nice. So some lovely answers coming through from you guys. 4 by 3 by 3 by 2. Okay, which would be 72 different ways. That is correct. Okay, because if there are 4 ways that we could go from A to B, when we go from B to A, and we don't want to go back one of the ways that we came, there would be 1 less way. When we go from B to C, we've got 3 different ways that we could go. Again, if we don't want to go the way that we go back the way that we came, there would be 1 less way. So that's why it's 4 by 3 by 3 by 2. Okay, does that make sense to everybody? Are we all good? Sorry, this is supposed to be 72. I see I've written it very badly. Do my 2 a little bit better. There we go. Not okay, Siha. Well, what's wrong? Where did we lose you? Okay, because it says here, if the person doesn't want to use a bus line more than once. Okay, so one of the bus lines that you used to go from A to B, when you go from B to A, you are not allowed to use. Does that make sense? And it's the same idea when you go from B to C. There's 3 ways that you can go from B to C. But if you've used one of those ways in getting from B to C, when you go from C back to B, you're not going to use one of them. Okay, so there would be 1 less. Does that make sense, Sihawu? Okay. All right. So let's go and have a look at this. Right. So we've been speaking a bit about factorial notation, right? And when we talk about people, people can never ever be repeated, right? Because people are unique, not like letters and digits. So if we want to seat 6 different people in 6 different seats in a movie theater, once one person sits down in a seat, that seat's gone, that person's taken it. There are 5 people left to fill 5 seats, 4 people to fill 4, etc., etc. So here we would say that there are 6 factorial ways in which we can seat people in a movie: 6 by 5, by 4, by 3, by 2, by 1. Okay. But what happens if we have more people and less places, like we have in example number 7? So now we want to fill 7 vacant places, but we've got 10 people. Can we still do the same thing that we did in example 6 and simply just say 10 factorial? Can we do that? No. Okay. So what can we do, Lesedi? If we're not allowed to do that, what can we do? No, we can't. Quite right. So how are we going to answer this question? If we're not allowed to do that because it doesn't make sense, yes, Lesedi, go for it. Lovely to hear your voice.
Hi, ma'am.
Hi, Lesedi.
Ma'am, I think we can say 10 factorial multiplied by 9 by 8, and then 7, 6, 5, and then we stop at 4 factorial.
You stop at 4, so you want me to stop over there. So that's place number
Yes.
1, number
1,
2,
2, 3,
number
4, 5,
3,
6.
4, 5, 6. Is
And then by
Lesedi?
3.
Oh, and
By
by
3.
3. Oh, by 3 as well, because that would be the 7th place. Okay, so thank you so much, Lesedi. That's awesome. I see Letu has also sent me 10 by 9 by 8 by 7 by 6 by 5. Okay, but Letu stopped at 4. I missed 6. Oh, yes, I did too. Sorry, that was a bit silly of me. Okay, so Letu, what you said was correct. I'm sure this is what Lesedi meant, but I didn't write the correct thing. Okay, well then, in Konaiza, that's a good question. All right, it would still be 6 factorial. Okay, because there are 2 seats that are always going to be vacant. Okay. All right. So now I just want to discuss with you before we move on a different way of setting this out. Okay, and it's what we were talking about earlier. I think it was Sihawu. I can't remember. Someone, there we go. Chrissy, good. Well done. So what Chrissy has sent me is this: 10 factorial over 3 factorial. Or another way that you can write this as 10 factorial over 10 minus 7 factorial. Okay, so you can do, yes. All right, so an easier way of, instead of writing it out 10 by 9 by 8 by 7 by 6 by 5 by 4, you can say 10 factorial over 3 factorial. Okay, and we do that because we want to get rid of the times 3 times 2 times 1 at the end. That's why we divide by the repetition, okay, the 3 factorial. Does that make sense to everybody? All right, well, you all seem to be happy with that. Cool. Okay, so now let's give you some questions to answer. Okay, so let's fly through those. and then we can look at something different. Okay, so let's have a look at 1A, B, 2, and 3. You guys answer those, and then you can DM Yolanda and I your answers. Okay, so everybody's going to try these by themselves. Okay. Cool, Lesedi. Good and Bali. Nice Hawa. Cool, Chloe. Blessing. Good, Katleho. Okay, Lesedi. Katleho. Good, Blessing. Nicely too. It's okay, Lesedi. Don't be scared. Just try. Okay. Nothing will happen if you get it wrong. Okay, just give it a go. Mamahle, I like it. Good, Letu. Inkonizer. Very nice. Well done. Which one? Number 2. Yes. Blessing, that's good. Letu, that's right. Oh, shame. Zonaka. Okay, so we're busy doing the fundamental counting principles, Anaki. You're probably going to be a little bit confused. We're just answering these questions that are on the screen at the moment. People are just DMing me their answers. Yes, Lesedi, that's lovely for number 2. Chloe, let's see what you're saying. Yes, that's right. Nkaniza. Yes. Good, Blessing. Amahle. Okay. Amahle. What you've sent me, your numerator is not correct, but your denominator is correct, Amahle. Just look at your numerator. Yes, Litlu, good. Yes, Katleho. Yes, Masejo. Yes. Jude, all good. Yes, that's right, Iola. Good, Lesedi, perfect. Okay, so Katleho, we're going to go through all of them now. Okay, and all the different ways in which we could write our answers. Okay. Oh, I'm sorry you just feel like you're just multiplying stuff together without really understanding it. That's obviously not what we want at all. Okay, thank you so much. You've all sent such good answers. Most of what I saw was correct. So that's really, really encouraging. Okay, so let's just go through this together before we go and have a look at something else. Okay, so Katleho, if you have a look at 1A, there are 8 places filled by 8 different people. So people cannot be repeated. Once a person sits down and takes the place, that's it. Okay, so that has to be 8 factorial. Okay, 8 by 7 by 6 by 5 by 4 by 3 by 2 by 1. Okay, so anyone who had 40,320, that was perfectly correct. Now, in part B, right, we've got 5 places filled by 15 people. So there are 15 people for the first block, 14 people for the second, 13 for the third, 12 for the fourth, and 11 for the last. That is the same as saying 15 factorial over 10 factorial. Or you can write it as 15 factorial over 15 minus 5 factorial. Sorry, that's a little bit small. Okay, so that would be 15 by 14 by 13 by 12 by 11. So that's 360,360. Katleho, do you understand why it's 15 by 14 by 13 by 12 by 11? There are 15 ways to fill the first, because there's only 5 vacant places. So 15 ways to fill the first place, 14 ways to fill the second, 13 ways to fill the third. Okay, you understand that, but cool. Okay. Questions 2 and 3 are very similar to question 1B. Okay, so we've got 10 contestants, a first, a second, or a third place. So there are 10 ways we can fill the first block, 9 ways we can fill the second, 8 ways we can fill the last. So that would be 10 factorial over 7 factorial. Okay, it would be another way of setting it out. That's where we get 720 from. Well done, everyone. And again, Katleho, it's the same idea with the last block. Okay, they're going to employ 4 teachers. They have a choice of 20. So there are 20 people to fill the first post, 19 people to fill the second post, 18 people to fill the third post, and 17 people to fill the last post. So you can write that as 20 factorial over 16 factorial. Okay, or 20 by 19 by 18 by 17. Okay, which gives us the 116280 that you sent through. Okay, Katleho, is it making more sense now? Cool beans. Okay, so let's have a look at the last question here. This is question 6. We'll just try and do this as quickly as we can because obviously Yolanda will want to run her poll shortly. All right, so we'll just see where we get to. Maybe we won't be able to do all of them. So in this particular question, we are making a 4-digit code. Okay, so there are 4 blocks to be filled. And we are using digits 0, 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so how many digits is that? If we're allowed to use the digits from 0 to 8, inclusive, how many digits? Good, it's 9 digits. Okay, and we're making a 4-digit code. So in part A, how many different codes are possible if the digits can be repeated? What do you guys think? Okay, so a lot of people saying 6,561. Okay, because there are 9 ways to fill the first block, 9 ways to fill the second, 9 ways to fill the third, 9 ways to fill the fourth. So that's 9 to the power of 4. Okay, which is where you get your 6561 from. Okay, because repetition is allowed. In part B, it says how many different codes are possible if repetition is not allowed. Good, Chloe. So Katlejo and anyone else who was confused here, good. No iPhone, that's not right. Careful. Unless Chloe was wrong. Hang on, let me just double check. Oh no, Chloe, sorry. Your answer was wrong. Everybody else's was correct. My apologies. Sorry, Chloe. Yeah. Quite right. Okay, because there are 9 ways to fill the first block, 8 ways to fill the next, by 7 by 6, because repetition is not allowed. So we can either say 9 by 8 by 7 by 6, or we can say 9 factorial over 5 factorial. So that gives us 3024. Good. Well done, everybody. Let's do question C. How many codes are numbers that are greater than or equal to 4,000 and exactly divisible by 2? Digits may be repeated. Oh, you see what you did. Oh, good. How are we going to do question C? How many codes are numbers that are greater than or equal to 4,000 and are exactly divisible by 2? Okay, so how many options? No. Okay, so let's do it like this. Fill in the first block. How many options do you have to go into block number 1? It has to be greater than 4,000, so it can only be a 4 or a 5 or a 6 or a 7 or an 8. It can't be a 0, a 1, a 2, or a 3, because it has to be greater than 4,000. So there are 5 options. Lovely. Well done. Now go to the end. If it's exactly divisible by 2, what number does it need to end in to be divisible by 2? It can only end in a 0 or a 2 or a 4 or a 6 or an 8. Okay, good, Letu, nice. Okay, so here there are 5 options. Right. If digits can be repeated, then we can use any one of the 9 digits over here and any one of the 9 digits over there. Okay, so good. You were quite right. 5 led to 5 by 9 by 9 by 5. And I'd really like to do the last question with you. So 2025 is correct. Okay. How many codes are numbers that are greater than 4,000 and are exactly divisible by 2? Okay, so Chloe, it has to be a 4 or bigger in the first block. So that gives us 1, 2, 3, 4, 5 options for the first block. If it's an even number, it has to end in a 0, a 2, a 4, a 6, or an 8. That's why we have 5 options. So here it has to be 4, 5, 6, 7, or 8. Repetition is allowed. There are 9 digits. So 9 digits could go here, and because repetition is allowed, there are another 9 digits that could go there. Okay. So in other words, the number that sits in this first block here, Chloe, has to be a 4 or a 5 or a 6 or a 7 or an 8. Okay, no problem. So can you see that questions C and D are very much the same? Read carefully. How many codes or numbers that are greater than or equal to 4,000 and exactly divisible by 2? The digits can be repeated. In question D, it says how many codes or numbers that are greater than 4,000 and are exactly divisible by 2? Sorry, Lihu. Sorry, iPhone. So it's in the words here, greater than or equal to 4,000. Okay, so including the number 4,000, listen carefully, including the number 4,000, there are 2,025 numbers that are greater than 4,000 and divisible by 2. So now, no, if you want codes that are greater than 4,000 and are exactly divisible by 2, you'd have to take 1 away. So you'd have to say 2025 minus 1. Why are you minusing 1? Because of the 4,000. You are excluding 4,000 now. So it would be 2024. I don't think anybody saw that one coming. Okay, so it's in the words. It says greater than or equal to 4,000 in question C. Right, in question D, it just says greater than 4,000. So the number 4,000 is excluded. So that's one less number. So that's why it's 2024 and not 2025. Codes. Okay. I think Yolanda wants to run her poll.
Yes, I want to run my poll. So
Okay,
please
please answer the poll. Please do the
answer
poll.
the poll
And
before you go. Thank you.
okay, so Katleho R, if it has to be greater than or equal to 4,000, okay? The first block is where you would put the 4. The second block is where, so that's how you would make the number 4,000. Okay, it's by the options that you've got in this block, the options you've got in that block, the options you've got in that block, the options you've got in that block. Okay, so we're talking about how many options do we have for each block. Okay, so in other words, the number in the first position here, that is in your thousands column. This is okay, so this is your thousands column. Right, this is your hundreds column. This is your tens column. This is your units column for the number. Okay, so if you have a look at how many thousands you can have 4,000, 5,000, 6,000, 7,000, 8,000. So that's why there are 5 options for the thousands block. For the hundreds and the tens, repetition is allowed. So that's why we've got 9 options for each of those. For our units block, it has to be divisible by 2. So it has to be an even number, 0, 2, 4, 6, or 8. Does that make more sense to you? Okay, there we go. No problem. No problem. Oloratu? Yes.
Poll.
Yeah. Oloratu, did that help?
Yes, ma'am.
Okay, so think about it like that. Okay, that first block is where your thousands go. The second block where your hundreds go. The third block where the tens go, and the last block where your units are. Okay, and then it maybe makes a bit more sense.